Hey, welcome back everybody. Thanks for watching. So today we want to discuss, am I ready for ordinary differential equations, aka DiffEqs? So I want to talk about what you need to review from pre-calculus, Calc 2, possibly Calc 3, and definitely linear algebra to be successful in differential equations, but also to get the most out of the theoretical aspects of differential equations, which are actually quite beautiful. Okay, so first let's talk about algebra and more that you need from pre-calc. So you want to review factoring polynomials at the level of quadratics, cubics, quartics, and, well, some quintics. So you want to review the rational roots theorem. That's going to become very important in differential equations. Look over Descartes' rule of signs. That could save you a bunch of time. Look over how to find the zeros of polynomials and the multiplicity of roots and what that tells you about the polynomial. Look over, of course, exponentials, exponential equations, logarithms, logistic equations. That'll come back. And look over trigonometry, of course, unit circle, properties of trig functions, etc., and odd and even functions. So all super, super essential. Now let's talk about what you need to review for differential equations that comes from Calculus 2. This is going to be a big one for a lot of you. So you need to know this material and know it well. So from Calc 2, or single variable calculus, integration by substitution, of course, integration by parts, trig integrals, integration by trig sub, and a big one that we use a lot in differential equations is integration using partial fraction decomposition. You want to look over sequences, power series, Maclaurin series, and Taylor series, and also representations of functions as power series. So all hugely important topics from Calculus 2. You can review those all and do problems using the free open source textbooks at OpenStax. Okay, so from Calc 3 or multivariable calculus, this is not required, but it makes life better if you're familiar with these topics. So it's nice if you're familiar with partial derivatives, vector fields, and especially conservative vector fields and how to find potential functions. Now let's talk linear algebra. This one is huge. A lot of the driving theory of understanding differential equations is from linear algebra. So from linear algebra, of course, you want to review row reducing and determinants, trace, linear combos, linear independence, huge ideas, span, basis, vector spaces, subspaces, eigenvalues, eigenvectors, eigenspaces. Your experience in DiffEqs will be much richer if you're familiar with all of these topics and understand them deeply. Also, as a little caveat, it's helpful to look over the matrix exponential e to the a if your class covers solving systems of differential equations. Now again, for resources, so I'll link these down below. So at OpenStax, I love this. I'm not affiliated with them at all, but I just love what they provide for students. They've got a free, full pre-calculus text. Calc 2 and Calc 3. And for linear algebra, this is not OpenStax. There are open source books out there, but I absolutely love Linear Algebra 5th edition by David Ley. It's an excellent textbook. Okay, so I wish you luck. Spend the time, go over these topics. You're going to have a much better time in differential equations. It's a beautiful subject. It's well worth your time to brush up on these.